Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, we're going to want to use our sum of cubes formula. So if we have a cubed plus b cubed, that's going to be a plus b, and then a squared minus ab plus b squared. So we're going to have m plus 4n, m squared minus 4mn plus 16n squared. And so that would be your answer for the factoring. For the math knowledge question, I'm going to start by rewriting all of our inequalities so that they're all turned the same direction. So C is less than D, E is less than C, B is less than E, and A is less than B. So if you look at the bottom one, A is less than B, but B is less than E, but E is less than C, and then C is less than D. So D has to be the biggest number because all of them are less than D. Okay, so we are looking at lesson 46 today. We're dealing with related rates problems. So hopefully after this lesson you'll understand related rates problems. So a related rates problem is a problem that gives you a situation and then one or more of your quantities are changing, and it asks for the rate when one of the quantities is changing. So we're going to have to set up some equations and then take differentials of them to be able to figure out what they're asking us for. So first you're going to make an equation that relates your variables in your problem. However many variables you have should equal the same number of rates that you're given. And you want to make sure those are the same before you differentiate. So let's look here. A 13-meter long ladder leans against a vertical wall. So we're going to go ahead and draw that out. So the ladder length is never going to change. It's going to stay as 13 meters. The base of the ladder is pulled away at the wall at a rate of 1 meter per second. So this is our base, and the rate of change is our derivative. We talked about that a few lessons ago. So the derivative of b is db, and it's with respect to time, so over dt. They want us to find the rate at which the top of the ladder is falling. So this is the height of the triangle. So we want to know what is our dh, because that's the derivative of h, and then with respect to time. I want to know what is our dh over dt. So the first thing that we have to do is to set up an equation with our b, h, and 13. So we have a right triangle, so we can use Pythagorean theorem. So b squared plus h squared equals 13 squared. And then we're going to take differentials. So the differential would be 2b db, and then 2h dh, and then equals 0. And we're going to divide everything by dt because we're doing with respect to time. And it wants us to find dh over dt. So let's solve for dh over dt. So we'll have 2h dh over dt equals negative 2b db over dt. And then we want to divide by 2h on both sides of our equation. And so dh over dt is negative b over h, and then db over dt. So they told us that db over dt was 1, so we can go ahead and plug that in. And then they said, what is the rate when the base is 5? But we still don't know our h. So if our b is 5, coming back up here, we can use Pythagorean theorem to find our h. So 5 squared plus h squared equals 13 squared. And if you solve that, h equals 12. And so the rate at which the top is falling is -5/12. And so that would be your answer there. So that's how you do a related rates problem with a triangle, with a ladder. You don't plug the 5 in at the beginning. You don't start with 5 squared plus h squared equals 13 squared, because then you won't end up with your dB over dt and your dH over dt. You start with your variables and you get your equation, and then you go back and plug them in. Okay, we're going to look at another example. We've got a 6-foot tall man walking straight away from a 15-foot high streetlight. At what rate is his shadow lengthening? When he is 20 feet away from the streetlight, and then he's walking away from the light at a rate of 4 feet per second. So we've got a man here. This is the man. And we've got a streetlight. So this man is 6 feet. And if you look, we're going to have two right triangles, similar right triangles. And the streetlight is 15 feet. And so we want to know about the distances down here. And so I'm going to label this one here as L. And this one here as X. So from here is X, and then from here to here is L. So if we set up proportions, L over 6 would equal L plus X over 15. You can set up the proportion a different way if you would rather. But if you cross multiply, you'll get 15L equals 6L plus 6X. And then 9L equals 6X. Okay, so that's our equation that we have. We want to use the 6 and the 15 because the height of the man and the height of the streetlight don't change. Same thing as why we used the 13 on the ladder, because the length of the ladder did not change. So we're going to need to take the differential here. So the derivative of 9L is 9, and then the differential is DL. And then on the other side, the derivative of 6x would be 6, and then with respect to x. And then we're going to divide by dt on both sides, because we're with respect to time. So it says, at what rate is his shadow lengthening? So his shadow is dl over dt, the rate that his shadow is lengthening. And he is walking away from the light, that's our x. So the rate that that's changing would be dx over dt. And they tell us that that rate is a change of 4. And this is the one we are looking for. And it says when he's 20 feet away, so that's when x is 20. But if you look over here, we actually only have dl over dt and dx over dt. When we took the derivative, the x went away, so we don't need to plug the 20 in. And that's because it's a linear change. He's in a line, and so it won't change whether he's 20 feet away, 15 feet away. It's always going to be the same dl over dt. So we're solving for dl over dt, so I'm going to divide by 9 on both sides. And then if I plug in what dx over dt is, it's 4. You can simplify that. I get 24 over 9, which if you divide by 3, gives you 8 over 3. So the rate his shadow is lengthening, 8 over 3 feet per second. I'm going to go back to the last one real quick. It was negative, and the negative is important just because it's falling, and so when you find it using your calculus information, you should get a negative. So that should help you know, okay, yeah, I did do it right, because it is supposed to be negative because it's going down. On this one that we just finished, it should be positive because he's walking toward or away from it at a rate of 4, and so the length of the shadow is going to be changing. It's also going to be a positive number. Okay, so we're going to look at another one with a cone. We've got a conical section. Container has a height of 9 and a diameter of 6, and it's leaking water at a rate of 1 cubic centimeter per minute. Find the rate at which the water is changing when our height equals 3. Alright, so you're going to start with your volume formula. And the reason I know we're starting with volume, they tell us it is leaking water at a rate of 1 cubic centimeter per minute. This is a volume change. So we know if it's leaking water, that means that our volume is changing. So dV over dt. And it's leaking, so it's going down by 1. Okay, so if we look over here, if we take the derivative of this, we're going to have to do product rule because we have an r squared and we have an h. And so what we need to do is to figure out how to replace one of those with the other variable. So let's go back over here and we can set up ratios. H to 9, the height of the little one to the height of the total, equals the radius of the little one, 2r, over the radius of the big one, which is 6. And so if we cross multiply, you get 6h equals 18r. And if you divide by 6, you get h equals 3r. So now we need to know, do we want it in terms of h or in terms of r? So it's asking us about h, so we need to keep h in the equation. So we don't want to plug this in. So r would equal 1/3 h. That's what we're going to want to plug in, because it says find the rate when h is changing. So the volume is 1/3 pi. Instead of r, we're going to say 1/3 h squared h. And so now if we simplify that, 1/3 squared is 1/9, and then we have h squared and then times h. So that would be 1/27 pi h cubed. So now that we have it in terms of one variable, we'll take the differential. So the derivative of v is 1 with respect to v over dt. this 1 over 27 pi is all our constant, our number. So we don't take the derivative of this part. We just take the derivative of the h cubed. So 3 comes to the front, so 3 over 27 is 1/9 pi, and then h squared, and then dh over dt. Okay, so we already know that dv over dt is -1, and then negative 1/9 pi. It says when h equals 3, so we can plug in h, and it wants to know the rate at which the level h is changing. So what is our dh over dt? So we're going to simplify this first. So we get -1 equals, this is 9 and 1/9, so those cancel, and we're just left with pi dh over dt. And so dh over dt is -1 over pi. And so that would be your answer. And the units would be centimeter per second, because the height is in centimeters and the time is in seconds. So that's how that one would work. And it is a negative because it's decreasing. The water is getting smaller and smaller and smaller. And so our answer should be negative. All right, we're going to look at one more. Air is pumped into a spherical hot air balloon at a rate of 25 cubic feet per minute. Find the rate of change of the surface area when the radius is 5 feet. So let's come back up here. This cubic feet is volume. So we need to start with our volume formula. So 4/3 pi r squared. Nope, not squared. Cubed. 4/3 pi r cubed. And so it tells us the dV over dt is 25. Rate of change of the volume. So if we take the derivative of this, 1, and then with respect to v, the derivative, again, this 4/3 pi, this is all some number. So we really just need to look at r cubed. So if we take the derivative, we're going to move the 3 to the front. So 4/3 times 3 is 4 pi r squared dr. And so if you divide by dt, because we're taking with respect to time. Notice that 4 pi r squared is your surface area. The derivative of volume is surface area. Okay, so we can plug in 25 here, and it says when the radius is 5 feet. So 4 pi, radius is 5, and we don't know dr over dt, so we can find it. So 25 equals 4 pi times 25 dr over dt. So that 25 will cancel to make that just a 1. So our dr over dt is 1 over 4 pi. Okay, but if you look back, it wanted to know the rate of change of the surface area. We just found the rate of change of the radius. So we need to go to our surface area formula. Don't erase this. You had to do it to find the rate of change of the surface area. So the area formula for a sphere is 4 pi r squared. So if you take the differential, you get dA equals 8 pi r dr. And then divide by dt, because you're taking with respect to time. And so we're looking for dA over dt. So they told us when the radius was 5. And then had we not just worked through this, we wouldn't know our dr over dt. So our dr over dt is 1 over 4 pi. And so the pi's cancel, and we have 40 over 4, which is 10. And then the units on the surface area, well, the units are feet, so surface area is feet squared per minute. So that is the rate of change of the surface area. Okay, so those are the 4 types of related rates problems that you're typically going to deal with. All 4 of them show up on tests throughout the year, so you need to make sure you are familiar with all of them. You practice them. As you practice them, you will get better at them. So anyway, hopefully that helps you a little bit with related rates problems. Your homework tonight is 1 through 25, so make sure you do those so we can go over any questions you have tomorrow.